Now, next term is the optical center. So, optical center is that point on the principal axis such that any ray passing through this point, right? Any ray passing through this point will emerge in a direction parallel to the direction of incidence. So, this is a convex lens I have considered, and this is a thick lens. You can see it is a very thick lens. So, this is a ray of light which is incident on lens, and if the lens was absent, the ray of light would have passed along this direction, right? This is the original direction of incidence. So there are two surfaces, okay? So the refraction will take place at the first surface as well as at the second surface. But we can see that the emergent ray seems to be parallel to the direction of incident ray. So then definitely this refracted ray which is present inside the lens is passing through a point on the principal axis which will be called as optical center O. So optical center is that point inside the lens on the principal axis such that a ray of light passing through it will emerge parallel to the direction of incidence. Again, optical center is that point on the principal axis inside the lens such that a ray of light passing through it will emerge parallel to the direction of incidence. Here also you can see that this is the incident ray and this being the principal axis, so the ray gets refracted at the first surface, it gets refracted at the second surface, and the emergent ray seems to be parallel to the direction of incident ray. We can clearly see. So definitely the refracted ray inside the lens will intersect the principal axis at a point O. Here O is called as optical center. So here also optical center is that point on the principal axis such that the ray of light passing through it will emerge through the lens in the direction of incidence, in a parallel to the direction of incidence. But what we can see that I have already explained you that a lens is nothing but a combination of two prisms, okay, and the central portion of the lens is nothing but a rectangular slab. So definitely a ray of light passing obliquely through a slab will have some lateral shift. We have studied this in the refraction of light, and from this figure you can clearly see that there is some lateral shift between the incident ray and the emergent ray. That means a ray of light passing in this way will be laterally shifted, and lateral shift can be easily observed. But if we consider thin lens instead of a thick, this lateral shift is very small and you can ignore it. So remember, in case of thin lens, refraction will take place at the two surfaces, at the first surface as well as at the second surface, but the shift will be so small that it can be easily ignored. Now in this case, if I draw a ray of light passing through optical center, it will be directly like this. Definitely this point will be optical center, and here a ray of light passing through optical center, okay, will travel like this. So what we have considered that if we have thick lens, the ray of light passing through optical center will travel in the direction of incidence, but there will be some lateral shift. You can see this lateral shift, right? But in case of thin lens, this lateral shift can be ignored. And in our syllabus, if we draw a ray diagram, that lens which we are considering will always be a thin lens. That means the lateral shift through the lens will be simply ignored. So now from now onwards, if I talk about the definition of optical center, it is that point on the principal axis such that a ray of light passing through it will travel undeviated, and this definition is valid only for thin lens. So optical center is that point on the principal axis. Optical center is that point on the principal axis such that a ray of light passing through it will travel undeviated. It will travel undeviated.